Okay, this question gives us this system of 3 equations and 3 unknowns we want to solve by using matrices with row operations, also known as Gaussian elimination or Gauss-Jordan elimination. Then we're going to solve using Cramer's rule with the graphing calculator to help us with the computation. And finally, matrix inverses, again, also with the graphing calculator to help us. So we have x minus 3y plus 5z is 2. Negative 4x plus 10y minus 17z is negative 9. 3x minus 8y plus 13z is 6. We want to rewrite this as an augmented matrix. What do we see? 1x minus 3y plus 5z equals 2. Then we have negative 4x plus 10y minus 17z equals negative 9. And then finally, 3x minus 8y plus 13z is 6. So what's our goal? Let's remind ourselves. Upper corner's got to be a 1, which it is. That's our first pivot. So we're going to use that pivot to make zeros underneath. 0 here, 0 here. That's the first thing we've got to do. Now, how do we make this negative 4 is 0? Multiply this first row by positive 4. So we're going to say our new row 2 is positive 4 times the old row 1 plus the old row 2. Because 4 times 1 is 4 plus negative 4 would give me 0. So let's see, 4 times 1 is 4. 4 times negative 3 is negative 12. 4 times 5 is 20, and 4 times 2 is 8. Then we have negative 4 and 10, and negative 17 and negative 9. What does that give us? 4 minus 4 is 0. Negative 12 and 10 is negative 2. 20 minus 17 is 3. 8 minus 9 is negative 1. This is my new row 2. Row 1 stays the same. My pivot is still that 1. So row 1 is still 1, negative 3, 5, 2. Row 2 is 0, negative 2, 3, negative 1. And my row 3, we have to convert here next. 3, negative 8, 13, 6. So as you can see, the pivot is a 1, and I've got to turn everything underneath that pivot into a 0. We have this into a 0. How do I turn that 3 into a 0? We're going to multiply the first equation by negative 3 and add that to the third equation. So negative 3 here, we're going to say row 3 is negative 3, row 1 plus row 3. What is negative 3 times row 1? Negative 3 times 1, negative 3. Negative 3 times negative 3, positive 9. Negative 3 times 5, negative 15. Negative 3 times 2, negative 6. Add that to row 3, which is 3, negative 8, 13, and 6. And what do we get? Negative 3 and 3 is 0. Good. We want a 0 in that lower left corner. 9 minus 8 is 1. Negative 15 and 13 is negative 2. Negative 6 and positive 6 is 0. This is my new row 3. So row 1 and row 2 are going to be the same as before. We're going to create a new row 3. So row 1 is still 1, negative 3, 5, 2. Row 2 is still 0, negative 2, 3, negative 1. But row 3 is now 0, 1, negative 2, 0. Now what do I need? I need the middle term to be a pivot. I need this to turn into a 1. Well, I could divide everything by negative 2, but that's going to introduce fractions, which I'd rather not do. What I'm going to do instead is I'm going to switch row 2 and row 3. That puts the 1 in the middle position, and that will enable me to pivot. So that if I switch row 2 and row 3, this becomes my next result. Row 1 stays the same. 1, negative 3, 5, 2. Row what was row 3 is now row 2, 0, 1, negative 2, 0, and row 3 is now 0, negative 2, 3, negative 1. So my pivot has to be a 1. Now I could use this 1 to turn the negative 3 into a 0 and the negative 2 into a 0, but I'm going to just use back substitution. So I'm just going to go below, and then I will do substitution to finish the rest of the problem. So I've got to multiply this second row by what to get rid of the negative 2? Multiply the second row by positive 2. So the new row 3 will be 2 times the old row 2 plus the old row 3. 2 times the old row 2, 2 times 0 is 0. 2 times 1 is 2. 2 times negative 2 is negative 4. 2 times 0 is 0. The old row 3, 0, negative 2, 3, negative 1. And what do we get? We get 0, 0, negative 1, negative 1. This is my new row 3. We're almost finished with this procedure. So that replaces the previous row 3. So row 1 and row 2 are the same. 1, negative 3, 5, 2. Row 2 is 0, 1, negative 2, 0. And row 3 is 0, 0, negative 1, negative 1. Except I want this piece also to be a 1. I would like to make this a pivot. Now again, I could use this pivot to turn that negative 3 into a 0, but I'm going to choose not to. How do I turn negative 1 into positive 1? Multiply the whole row by negative 1. So we turn things into 1s by either multiplying or dividing. So my new row 3 is the old row 3 times negative 1, which will give me 0, 0, 1, 1. And that will finish my upper triangular version of this. So let's see where we are. Do we have? First row is 1, negative 3, 5, 2. The second row is 0, 1, negative 2, 0. Third row is now 0, 0, 1, 1. And this is finished because we have 1s on the diagonal, 0s underneath. Everything else can be gotten fairly easily with substitution. So that's how we finish this. Let's remember that it went x, y, z. X, y, z here. X, y, z. So the first equation is 1x minus 3y plus 5z is 2. Terrific. Second equation is 1y minus 2z is 0. The third equation is 1z equals 1. Okay, so fine, so z equals 1. So I'm going to back substitute. Now plug z equals 1 in there. So I get 1y minus 2 times, what is z? Z is now 1. So I get y minus 2 times 1 equals 0. I get y minus 2 equals 0. I get y equals 2. So we have our y equals 2, and we have our z equals 1, and those are going to get shoved in over here. So z equals 1 will be shoved in for that z, and y equals 2 will be shoved in for that y. So we get 1x minus 3 times y. What is y? Y is 2. Plus 5 times z. What is z? Plus 5 times 1. Equals 2. And we get x minus 6 plus 5 equals 2. So that's what? X minus 1 equals 2, adding 1 to both sides. And we get x equals 3. So we believe our answer is x is 3, y is 2, z is 1. Ordered triple. 3, 2, 1 is the point in space where those three planes intersect.